All right, so this one, there's a 50-kilogram cart that moves in a straight horizontal track. This is the graph of the velocity in the x direction versus the time for the cart. We have like several parts to this that we have to do. Part A is when is the cart at rest? So part A, when is it at rest? And so what we're really looking for, it's at rest when the velocity equals 0. Okay, so right here, remember this is the velocity. So the y value, if you want to think of it in terms of x comma y, occurs at 4 seconds, comma 0 meters per second. Okay, and then also over here, that occurs at 18 seconds, comma 0 meters per second. Now, I think some people would be tempted to think that this is when it's sitting still. It's not, because that's if it was a position versus time graph. So the answer is when t equals 4 seconds and when t equals 18 seconds. Now for part B, it says, no way, did that fall in there? It sure did. For part B, it's asking every time, indicate every time the interval for which the speed, magnitude, or velocity is increasing. So the speed is increasing when the slope is positive. So we're going to say increase speed slash positive. And so what we're looking for is a positive slope. So let's highlight that. From here to here, it's increasing, and from here to here, it's increasing. So we're just going to go and find those times. It looks like from 9 seconds until 12 seconds. Let me just double check here. 9 seconds until 12 seconds.
Wait. Dude, I'm really confused.
Wait, let me think for a second. Actually, I gotta come back. It's not gonna be the positive slope. It can also be a negative slope. So, for example, remember speed is just talking about magnitude. It's not talking about direction. And so we got to talk about that. So right here, the velocity is about 0.8 meters per second. It's decreasing. But now from here on down, we go from 0 meters per second to a negative 1 meters per second. That's an increase in speed in the negative direction, right? So that one is going to be an increase in speed from the time 4 to 9 seconds. That one's a little challenging. And then from here, our speed is technically decreasing, right? Because you're going from a negative 1 in the negative direction and you're slowing down. So that's a little bit of a challenge. And then here it just maintains its speed, then it slows down again. Now this is the hard part here. When does it increase in speed? Well, this has got a negative, negative, negative. It's approaching 0, but from here to here, it's got an increase in speed. So that is going to be, what is that, 18 to 20 seconds?
You can complain. Sometimes you should do it better.
Hold on, I'm recording a video. Do you have a question on something?
Number 5.
All right, just wait 1 second. Let me finish this. Now for part C, determine the horizontal position of the cart at 9 seconds. If the cart is located at 2 meters per second, or I'm sorry, 2 meters. So for part C, I didn't say it right, but they're saying that the initial position is equal to 2 meters. They want to know the final position when the time is at 9 seconds. Now, in order to find that, I only need one other thing. I need to know, let me think here. I know so from 0 to 9 seconds, this is an interesting one. So from 0 to 9 seconds, I have an acceleration, but I also have an initial velocity. So the initial velocity is 0.8 meters per second. I'm getting that from here because that's what the velocity is. At 0 seconds, the velocity is 0.8. And then the final velocity is going to be at 9 seconds, the final velocity is -1. So at 9 seconds, my final velocity is -1 meters per second. Meters per second. And then you can figure out the acceleration because that's just the slope of the graph. And since it's linear, it goes from. How would you do that? You would say it goes down -8, so that would be -0.8. It's just the slope over 4. And so we would have to do that, divide the top and bottom by 4, and you get -0.2 over 1. So that's the acceleration. So the acceleration should be -0.2 meters per second squared. 0.2 meters per second squared. So then the final position, x, is equal to the initial position plus the velocity, the initial velocity times time plus 1/2 times the acceleration times time squared. That's it. And so my initial position is 2 plus the initial velocity, which is 0.8 times 9 plus 1/2 times -0.2 times 9 seconds squared. So this becomes 2 plus 7.2. Actually, I'm just going to use a calculator for this. So let me just jump in here to Desmos. So we've got 2 plus 0.8 times 9, plus 0.5 times -0.2 times 9 squared. So this is saying that it went backwards. Let me think for a second. I think I misread the question. Huh.
Not pretty sure. I'm not even gonna try and figure out how you got that. I have nothing screenshotted of anything. I would never do anything to get caught lacking. Yeah, for sure. In general.
Oh, they separated it.
Anna's being quiet. Anna's that's what I mean. I haven't. I'm not gonna come back. You seem pretty nervous though. Maybe Anna's she wants to share with everybody. Yeah. It was bad.
I did read it wrong.
I won. That'd be pretty tough. That'd be great. If I get enough to and then walk on basketball, that'd be high. And then just defend or the basketball here.
No, I did it right. I must have entered it in the calculator wrong. So I have 2.
Purdue had a 53%.
Oh, okay. All right, I think I got it. Determine the horizontal position if the cart is located at 2 meters at t equals 0.
I love his video. He's like college life in my bedroom. Looking at the camera, it's like, what? It's like, walking upstairs, and he's pretty so sexy.
Oh, I know. Well, that's the final. So when I do the math on this, they do it slightly different. They're saying that if you subtract, if you neglect this,
They're funny to watch. Really. It's like what?
then you have delta x. And if you do it this way, so somewhere I think I made a mistake, equals all this stuff. So then if you do it this way, then delta x is equal to all this stuff minus this. But I still think I'm plugging something in wrong. Oh, I see what the problem is. No, I had it right. All right, let's try this again. That's part of the problem. So if I say 2 plus 0.8 times 9 plus 0.5 times, that was the mistake I made, negative 0.2 times 9 squared. There we go. All right, so I had it right. Everything I had was right. I just plugged it in the calculator wrong. So we don't need to do all this stuff. I was trying to figure out what I was doing wrong. So this was correct. This should be x equals 2. And then the final position then, not delta x, the final position then is 1.1 meters. All right, come up here if you have